This is a fun problem. In this picture, every rectangle already has its area written inside it, and you can clearly see each value. For example, this rectangle shows the area as 16, and this one shows the area as 28, and the rest of them are also labeled in the similar way. The question is simply asking to determine the area of the rectangle that is colored in red using the information provided. So, can you solve it? A good way to begin is to look at a rectangle where we know the areas and therefore the sides are easy to describe. So focus first on the small rectangle at the bottom left, whose area is 8. Let the horizontal side of this rectangle be called x, and the vertical side be called y. Because the area of a rectangle is always the product of its length and height, this simply means that x times y equals 8. That gives us our first relationship. Next, look at the rectangle directly above it, whose area is 16. This rectangle shares the same horizontal side x, right? Now let us call the vertical side of this rectangle p. Its area tells us that p times x equals 16. Now we have two relationships, one linking x and y, and another one linking p and x. The neat thing is that both rectangles share the same x, so by comparing their areas, we can learn how p relates to y. From this, we can take y, this side, to get x as 8 over y. Then substitute this x value here to get 8 over y times p equals 16. Now take this y on the right-hand side to get 8 times p equals 16 times y. Now divide both sides of the equation by 8 like this. This 16 over 8 becomes 2, and thus we finally get p equals 2 times y. Nice. By the way, we could have obtained this relationship much faster by observing just one simple fact. Since 16 is exactly twice the 8, and both rectangles have the same horizontal side x, the only way the areas can differ by a factor of 2 is if p, or this height, is twice the value of y, or this height. This reasoning saves us from doing long algebra, and therefore please remember this fact for the rest of the question. We will be using the same trick again for the middle strip. Look at the horizontal rectangle in the middle bottom, whose area is 12. It shares its height with the bottom left rectangle, whose area is 8, right? So both have the same height, y. Now look at this thin horizontal rectangle in the middle, whose area is 6. Since 6 is exactly half of 12, and both these rectangles share the same horizontal side, or this one, the only way their areas can differ by a factor of half is if the height of this smaller rectangle is half the value of y, or this height. So this will be equal to y over 2. Great. Now what will be the height of this red rectangle? It's simple. It will be this, or the height of this small rectangle, or y over 2 plus this, or the height of this rectangle of area 12, or y. So the height of this red rectangle is simply y plus y over 2, which is 1.5 times y, or in fractions, it will be 3y over 2. Awesome. Now earlier we found that the rectangle with area 16 had height p, which equals 2 times y. That height plus the height y from the bottom gives a total height of 3 times y for the entire big rectangle, right? So what will be the height of this rectangle whose area is 28? It will be 3y minus the height of the red rectangle, or 3 over 2 times y, which is the same as 3 over 2 times y, right? So here comes the magic. The large top right rectangle of area 28 matches exactly in height with the combined stack of 3 rectangles of area 6, 12, and a question mark. Also, its width lines up perfectly with the same combined width of the small strip of area 6, the red rectangle, and the bottom middle rectangle of area 12. Because they match both in height and in width alignment, the area of the large top right rectangle must equal the sum of the areas of those 3 rectangles, right? So if we call the unknown area of the red rectangle as a, then the total of these 3 areas is a plus 6 plus 12, and this is equal to 28. The sum of 6 and 12 is 18. So the unknown area a must be 28 minus 18, which is 10. Therefore, the area of the red rectangle is 10, and that's it. This problem was super duper cool. Like, share and subscribe. So good.